Good morning, students. As we continue with the discussion on the biopotential measurement, today we will look on the signal, the electrooculogram. So the electrooculogram measures the cornea positive standing potential relative to the back of the eye. So this EOG is used in several diagnostic purposes, which is used to measure or to understand or how the nerves, the retina, the cornea, etc., the different eye functions can be monitored. So here the basic measurement, okay, so it's done by using electrooculography, so which is nothing but a technique which is used to measure the potential which is existing between the front and the back of the human eye. So normally during the time when there is a impairment or some accidents has been happen in the eye, we like to check the functions of the eye. So that's what we call it as the functional measurement of the eye. So the persons who are suffering from those functions, we call it as the functional impairment of the eye, or it can be a complete blindness or moderate or mild. Okay, so the measurement technique is called as electrooculography, and the signal which is measured, that is what we call it as the electrooculogram. So it normally measures the eye movements. So here we place the electrodes, either it will be the above or below the eye, or on the left or the right of the eye. So whenever there is a movement in the eye from the center positions towards the two electrodes which is being placed at the side or up and down of the eye, the potentials which is being generated by the movement of the eye, which has been representing the functions of the nerves, the retina and the cornea. So it has the positive element of the retina and the negative element of the retina. That means I'm talking about the potential. The difference of the potential is being measured, and that becomes the potential difference, or that's what we call it as the eye potential. That is the potential which has been measured from the positive side of the retina and the opposite electrode eyes, where it has been placed. So we measure the potential. So that technique we call it as the electrography, and the signal we call it as the electrooculogram, shortly called as EOG. So the measured potential is being between the two sides, and it's about the potential difference between the electrodes which is placed on the different side of the eye, which provides us the information of the eye movements, and that is how the signal is being transmitted within the nerve endings, and how those signals is been providing the functioning of the eye. So we have a disease called facial palsy, where the persons are suffering from the blinking of the eye. That's what we call it as the facial palsy. Okay, so the students who are interested, you can go through the case study from the hospital database on the facial palsy that we will see in detail in the next class. So normally the EOG, the electrooculogram ranges, the amplitude will be from 0.05 to 3.5 millivolt, and which is always proportional with the eye displacement. Okay, it varies between how the eye movements are there. So it's a electrical dipole measured. So it's a negative pole which is at the fundus and the positive pole at the cornea. So the eye movements varies, the potential is being recorded. So this is the electrode potential of the of which we have taken in the laboratory with the students. You can see how the electrodes has been placed at the different sides of the eye, and it's a surface electrode. So surface electrodes provide us a better potential acquiring, so that we will get the maximum potential by placing a surface electrode. That's also possible with the needle electrode, but normally for the basic measurements and the initial stage of diagnostics, we use the surface electrode. So when you look on the electrode setup, I am sharing the video of that. So now we will see the recording of how it is. You can see that the electrodes are placed in the on the person. So So it's been taken in the biomedical instrumentation laboratory. So see this. So this is the electrode setup. So you can see the electrode setup where the positioning of the different electrodes, and we have a options in the device instrument itself. So we first initially before starting the EOG measurements, we go with the self test, and an input square wave has been given for testing the equipment. And the EOG has been recorded. You can see that by using an USB, you can able to store the data from the digital oscilloscope. So the peaks in the graph which we can able to see represents the blinking of the eye. Okay, so you can see that the peaks is nothing but it's a representation whenever the person makes the eye blinking. So you can see that the signal can goes higher. So that's a recording setup, and after the recording, you can see that the blinking of the eyes. Here we made the person to blink rapidly. So you can see that there is 3 blinking, and we can see that the voltage level at the bottom. You can see that's kept at 5 volt, and the time period is kept at 250 milliseconds. So normally for each individual eye blinking, the eye blinking ranges from the time period ranges from 250 milliseconds to 500 milliseconds, and the amplitude, as in the theory just now we have seen that the amplitude is between 0.5 to 3.5 millivolt, but it depends upon the amplifier what we use. So in the laboratory we have kept the gain at the maximum, so we can able to get the peak to peak voltage of nearly 20 volt. From the diagram you can see that the peak to peak voltage, you can see that it's in 5 volt. So a single box represents 5 volts. So you can able to see that it ranges up to 12 volts. So it's about the gain of the front end where the amplitude varies. Okay, so we can able to vary the amplitude, and this is for 2 blink. So, okay, so you can see that how clearly it has been shown. So similarly, the time period stands at 250 milliseconds, and the voltages nearly we are getting from 15 to 20 volt. So this is we made the person to blink more rapidly. So there is 5 blinks, and we can see the amplitude ranges between some 15 volt to 20 volt, and the time period is ranging from 250 milliseconds to nearly 500 milliseconds. This is for the 5 blinking. So these are some of the EOG recorded in the laboratory. So that's the EOG. So the detail of these recordings will be discussed in the next class.